as we try and study these things into the future. Here's where Lake Mead is today. Okay? It's down. And even with this wet winter we've had, it's not really recovering all that much. Now, granted, storage in the Lake Mead and Lake Powell are about 50 million acre feet. I mean, they were designed to withstand long periods of drought. But this is rather concerning. Okay? So what do we do? So in Southern California, the engineers, tap water engineers, were figuring out, well, we have to diversify the supply, right? Have to diversify. And so in the early 1990s, where we relied a lot, for example, on the State Water Project, the current strategy is to rely a lot less on the State Water Project, a lot less. And we have to make that up with something else. Because remember I said to you, with this million acre feet from the state project, million acre feet from the Colorado River, million acre feet from local groundwater. So where are you going to make up that water? Do you conserve more? Do you develop more local water supplies? Is that how we're going to do it? And the answer is yes. Are we going to try and do more ag to urban transfers? The answer is yes, if we can. That's what we're trying to do. What is interesting about this pie chart, just for note, is this is still somewhat of a concern for us in terms of making sure we can maintain the Colorado River aqueduct at the levels that we hope we can. So our emphasis today, okay, emphasize conservation, local supplies, and I call them transfers, ag to urban transfers. Okay, let's talk about local supplies. Water recycling seems like the right thing to do. I mean, I'll tell you right now, the wastewater treatment plants that we have here in Southern California are tertiary treated plants. Okay, they go for multi-barrier treatment processes. Title 22 water that comes out the other end is very, very high quality water. We're not talking Jurassic Park technology from World War II. These are tertiary treatment plants. And that water has designated use for golf course, landscape, even groundwater recharge. And it's in our future. And LA pioneered a lot of that and continue to do so, and many, many other member agencies in Southern California, to make sure that we can at least use the recycled water. If I spend all that money to get it down here, I should be able to reuse it again. Okay. Groundwater. Believe it or not, there are groundwater basins, particularly in Ventura County, that flow, are full. In fact, they're flowing so full that people's, the streets are still getting flooded because the groundwater is not being utilized enough. Reason is, years ago, many cities says, well, we have imported water now, we don't need groundwater. It's kind of crummy groundwater, it's a little salty, we're not crazy about it. And so they abandon their wells. And of course now, when people are talking about developing local groundwater, they want to get those wells drilled again. Okay? Except now with the budget that we have in our cities, it's hard to get money to go and do that. And you can always blend groundwater. Right? Groundwater recovery. Groundwater recovery is basically trying to take groundwater that maybe is not potable water and make it potable. And you know what? It's not the contaminants that are the big deal. It's not necessarily the perchlorate issues, the chromium-6 issues. By and large, the issue we have with groundwater recovery is taking the salt out of that groundwater to make it potable, building desalting facilities to treat groundwater. It's a lot cheaper to treat salty groundwater than it is to treat ocean water. Groundwater salinity is about, let's say, 2,000 to 3,000 parts per million salt. Ocean water is about 30,000 parts per million salt. And of course, you can do the math in terms of just what that would be like. You're looking at order of magnitude differences in salt. If we can take a lot of the salt out of our groundwater, you're going to solve a myriad of problems. And it's not necessarily the sexy thing to talk about if you're in the water treatment business. Well, I want to get rid of that contaminant. I'm going to take care of this, this THC problem. It's really about the salt, by and large. The LA aqueduct, I think they're trying whatever they can to hold on to the supplies they had. I don't know, Fred, that's as best as I can say for that situation right now. And trying to develop some things up there with their system. And of course, desalination. Now, the desalination slide here is not the groundwater treatment one. It's ocean water desalination. You've heard a lot about ocean desal, and I'm sure you hear it all the time. Well, Christ, we live right there by the big water supply. Why don't we just run to the ocean and take all that water? I'm going to explain that to you here in a second. In any event, Metropolitan, that's you and I, made up that service area, part of what's on our water rates, have invested throughout the entire region to try to essentially develop more local projects, more water recycling projects, more groundwater recovery projects, anything we can do to sort of get ourselves off of the state project system for the frequency of time we need to be on it because of the issues that are out there. And they've made a lot of progress. And of course, we need to do a lot more. And at least as of this slide, which is less than a month old, they've already invested about $300 million to do so. So the strategy is, what I tell my students, and what you'll tell your children is, we have to meet our future demands through local resources. Right now, that's really where the strategy has to be. And that's exactly what Metropolitan has been trying to do, what the direction their board has taken to do just that. Invest more in conservation, recycling, and groundwater. I'm downplaying the ocean desal here for a second, but if you can do 1 billion gallons a day, but 1.1 million acre feet a year, you just serve the demands of those 3 large cities right there. So that's kind of a big deal. Okay. Watershed management. This is going to tie into my ocean desal discussion here in a second. Why do we manage watersheds at all in Southern California? We had never done that before for many years. The reason is because all these areas have to comply with federal and state regulations. We call that total maximum daily load compliance, and try to develop an effort that if we're going to have to comply with what you can discharge into a creek system, and that applies for everybody that lives in the watershed, then let's try and do it in a way that can actually develop a supply and save everybody money. And so I just happened to pick the Cayugas Creek watershed, so I spent most of my time working on there, just to show you that the different creeks that feed into that watershed basically import water dependent, that ultimately feed out to the ocean, got the involvement of many, many cities to do just that. And as of today, we're in the process of building a salinity management pipeline, which is a fancy word for brine line, because once you take the salt out of the water, you got to take it somewhere. You got to put it in the ocean, right? And also, build groundwater treatment facilities locally. And so there's discussions between Camarillo, Moore Park, Simi Valley, Thousand Oaks to start doing joint projects like that. And I'm sure those same discussions are happening here in LA County with many cities we have here. So watershed management is going to be around for a while, and it should be. It really is the direction we need to be going. So let me talk to you about costs, because I thought I would start with the cost issue and maybe kind of convey it that way. We got to hold us a marginal cost. This is by a paper by James Fryer, and I can send you the link to that if you're interested in. What is the marginal cost of ocean desalination versus water recycling or water conservation? Okay? And he came up with a range, and you'll see that the cost of ocean desalination still are about between $2,000 and $3,000 an acre foot. And many people will say, well, how can that be? Because I hear you can do it for much, much less. When I wholesale treated water to our cities, we were wholesaling that water under pressure, high quality water for about $800 an acre foot. That's your tap water. Tap water goes thousands of tests a year to make sure that it's safe to drink. Okay? So you have to compare that with what people are talking about going to the ocean, and basically what's going to cost us a lot more. Very energy intensive, very expensive, and typically somebody needs to subsidize those costs. So is the ocean our immediate answer? And my answer to you is no, it is not. And there are a couple of reasons for that. Number one, if I go to the ocean, most of the demand is still what? It's still uphill. So not only have to treat the water by the ocean, I'm typically have to pump that water uphill to get it back to my service areas. And you still have environmental issues you have to deal with. The environmental issues are not going away, and it's something we want to be cognizant of. Is there ocean desal in our future? Of course. Of course there is. But the one thing I always tell people and I've seen it over and over again, and I'll pick on my own cities. For years, while we had these issues going on with our local groundwater resources, cities did nothing, okay? Even when they're under orders to clean up the groundwater, because it was expensive. And the typical answer you'd get from particular administrations, they would sort of say, well, we'll let the next city manager deal with that. Let the next council deal with that. So the delay tactic was to do nothing, okay? And as years and years passed by, the problem just grew. And now we have a watershed. Many of our watersheds are in trouble. We focus our attention back on the watersheds, number one, because the regulations say we have to, but secondly, because water is such a precious resource. And if we can develop the precious resource locally, and even develop storage locally, then there's even more reason to do so. And when you talk about the watershed ethic, which is a great ethic to have, going to the ocean, it sort of invites the opportunity to turn your back on the watershed. Well, now we're just going to go to the ocean. Create a whole other set of problems with the ocean as opposed to dealing with the watershed issues and dealing with the regulatory issues and the cleanup issues that we all have to if we want to leave the area as good or better for our children than the way we inherited it. So cost is a huge, huge driver. And I would tell you that the cost that people portray in an S.U. Reed Fryer's paper are typically subsidized. Once you pull all the subsidies out of there, that's what you're dealing with. Okay? So how do consumers, as you and I just as consumers for a minute, how do we help? Okay? These are the typical statements that you would see, and there's a website called www.untitled